A ball is thrown across a playing field from a height of 3 feet above the ground at an angle of 45 degrees and a speed of 20 feet per second. It can be deduced from physical principles that the path of the ball is modeled by the quadratic function y equals -32 over 20 squared times x squared plus x plus 3. We are to find the maximum height and the horizontal distance the ball has traveled when it hits the ground. So first of all, let's simplify the value that we've been given for A. A is the opposite of 32 over 20 squared, which is the opposite of 32 over 400. 8 goes into 32 4 times and into 400 50 times. We can divide both the top and the bottom by 2 to get that A in simpler terms would be -2 over 25. So I'm going to rewrite the function as -2 over 25 x squared plus x plus 3. The B is equal to 1 and the C is equal to 3. We know that the maximum occurs at the vertex of the parabola. We can label that point HK. And the H there, we have a formula for it. It is the opposite of B over 2A. So it is the opposite of 1 over 2 times -2 over 25. So we can write that as -1 over -4/25. To divide by a fraction is the same as to multiply by the reciprocal. The product of two negatives is a positive, so we get 25/4. And so the H is 6 feet and a quarter, which would be 3 inches. From the H here is the horizontal distance where the maximum occurs. That's just a little over 6 feet from where the ball is thrown. The maximum height is going to be f of h, which will be -2 over 25 times 25/4 squared plus 25/4 plus 3. We can cancel one of the factors of 25. We can factor the 2 into one of the 4s. And so we have -25 over 8 plus 25/4, which is 50/8, plus 3, which is 24/8. So we get 49 over 8. feet, which is 6 1/8 feet. So 49/8 feet or 6 1/8 feet. Now, where does the ball reach the ground? We will then want to know where f of x equals 0. And so we're going to have 0 equals -2/5, or -2/25, x squared plus x plus 3. And we can use the quadratic formula this time to get that x will equal the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So -1 plus or minus 1 squared minus 4 times -2/25 times 3 all over 2 times -2/25. So, -1 plus or minus the square root of 1 plus 12 times 2 is 24/25 divided by -4/25. -1 plus or minus the square root of 49/25. And I got that because 1 is 25/25. Added to 24/25 gives us 49/25 minus 4/25 is the denominator. So -1 plus or minus 7/5 all over -4/25. So we have two different solutions, remembering that the -1 is the same as -5/5. We get 2/5 divided by -4/25 is times -25/4. The 2/5 comes from -5/5 plus 7/5. We have some canceling that can occur. So one of the possible solutions appears to be -5/2 or -2.5 feet before the ball was thrown. In this application, that doesn't make any sense. So it might work mathematically, but not in the application. The second possible answer comes from subtracting the 7/5. -5/5 subtract 7/5 is 12/5 times the reciprocal of negative 4/25, which is 25/4 negative. Again, we've got some canceling that can occur. So we get 15. And this is our solution for the application. The ball reaches the ground 15 feet from where it was thrown.